So hello guys, you are welcome once again to Mosty Academy, and today we are looking into chemistry topic we call ionic equilibrium. So this topic actually is a very large topic. When I say large, it's broad, but in this video we only focus on some important aspects which I have actually prepared some kind of slide to explain some important parts. And I'll be doing maybe 4 to 5 questions, which are exam type questions related to the topic of ionic equilibrium. So before you can watch this video, you need to subscribe to the channel and have an idea of the acid, base, and salt concept in your junior classes. I mean the definition of acid according to Arrhenius, Lowry, and as well as Lewis. Definitions and interpretation. You must also have an idea about conjugate acids and conjugate base. So if you have this deep idea, or let me say surface idea about this, you will be able to understand what we want to talk about based on what the topic before us. And all questions I'm taking are from the O level, which we call ordinary level, which is also important for what A level students in some cases. So let's get started with this short chemistry video of ionic equilibrium. Now, when we say ionic equilibrium, we are going to look first here. The first slide prepared by my admin here is the dissociation constants of a weak acid and a weak base. Now, from your study of classification of acid, you have talked about different types of acid, talking about how they dissociate. Those that dissociate wholly or totally are said to be strong, whereas those that dissociate partially are said to be base. Now, when we want to write the dissociation constants of weak acid and weak base under this topic of ionic equilibrium, we basically focus on the reaction between what? Acid and dissolving acid in water, talking about behavior of acid, talking about the reaction with what? Weak acids and what? And the weak bases. Now, here, let's consider what we call dissociation constant. Now, in chemistry, the dissociation constant is given as what we call, let's take a very simple solution which every one of us can ionize. Let's take water, for example. We take H2O as water. Now, if we ionize H2O, which is water, we are going to have, apologies guys, I just want to make sure this is better. We are going to have H plus and OH minus. That is, I have dissociated this substance. So if you now want to write the dissociation constant of this acid now, we can say it is the same thing as, this is water for example. I'm going to take a weak acid as an example. Now if we have a weak acid, which is ethanoic acid, CH3COOH, when this dissociates, it's going to give us the same way. We have a CH3COO minus and plus H plus. You can write H plus first, then you go with what? CH3COO minus. So if we go by the dissociation constant here, we can say the dissociation constant of this base, we can call it KB. Dissociation constant of base will now be the concentration, the dissociation rate in terms of active mass. That is putting something inside bracket. So it's going to be CH3, COO, then close the minus this. Then you have what? The other one, which is H plus, close the brackets. This bracket, we call it active masses under the topic of your equilibrium. You might have studied it in junior classes. Divided by that of the what? You can see product over reactant. I would love to make this a reversible reaction for you to understand better. Then it will be over active mass of CH3COOH. So what I'm trying to say here is that if you want to write the dissociation rate of an acid or of that of a base, it is always concentration of the acid divided by apologies, the concentration of product over that of what? Concentration of reactants. So always keep that in mind. This is very, very important. I hope students can see this. So now, this is what we want to talk about, writing the dissociation rate. Now, the question is, why are we learning this? And why do we need to learn this? Now, what we notice is that the dissociation rate of different substances differ from one form to another. For example, what am I talking about? Now, if you want to write the dissociation constant of water, you need to just listen, guys. Now, what we do here now is for water, it is kind of divided. The rate at which substances dissolve or split out differs from one another. Then we now notice that what is the cause of this effect? Now, what we notice is that the cause of this effect is nothing but what we call the pH of the solution. And in junior classes, if you remember, you have studied pH of a solution to be what? To be the measurement of the level of acidity and the alkalinity of a substance. So now, talking about the rate of dissociation. Now, the rate of dissociation of an acid is the measure of its pH and the pOH. For acid will be pH, and for base will be the what? pOH. So by and large, in a nutshell, what we're talking about here about dissociation constants of weak acid and weak base, we can consider acid, and if it is what? A base. Now, we can deal with this is more like ethanoic acid. If I dissociate, or basically most time we can see it in your textbook. Let me write it for you guys to see. If I write the first one as the first the base to be BOH, I ask you to dissociate this, it will be what? B plus OH minus. If I ask you if I want to get an acid, I'm taking acid as HA, but this is how way you are going to see it. It will be what? H plus, then plus what? A minus. So this is a B plus, then plus what? OH minus. So dissociation means splitting down. And if you want to write its constant, it is always going to be concentration of the product over that of the reactant. I hope students understand that. And if we understand that, admin, please, let's go to the next slide. Thank you very much. Now, having said that, we now move from what we call the dissociation constant, which we say is the measure of the concentration, to what we call the ionic product of water. Now, talking about the ionic product of water, let's take water just like what I did now. Water is written, basically, everybody knows that, as H2O. If we ionize water, we are going to have, I don't want to waste time on cleaning anything. If anything is not writing well, I'll just leave it the way it is and move on. Now, if we ionize water, we just talked about that reversible reaction. It will dissociate to give us H plus what? OH what? Minus. So if we write the K, let's say the dissociation rate of this, I'll call it Kp now, will now be equals to, we've talked about this, H plus, then that of OH minus is in there, over the product, the reactant is H2O. Now from here, if we cross multiply, most time you see it as Kc whatever. This is not equilibrium constant. We are talking about the rate of dissociation. So if we cross multiply here, we can say this is giving us nothing but Kp, I'm using Kp, multiplied by the concentration of water is equals to, this is H plus, and that of OH minus. Now this particular thing, because water is said to be neutral to pH, which is where we are going actually. You guys know that we can now say this particular value here, we have gotten here, can be called what we call the dissociation. I hope my spelling is correct. Constant of water. So the dissociation of constant of water is given as H plus and what? OH minus. Now, at 25 degrees Celsius, you can note this, at 25 degrees Celsius, you know, we say water is said to be neutral to pH if we are going there. Now, at 25 degrees Celsius, we say the concentration of H plus is given as 10 raised to power negative 7 moles per dm cube. Please listen, we are getting to where we are going. And that of OH minus, hydroxy ion, is also given as what? 10 raised to power negative 7 mole per DNK. So in general, we are now going to have, from your mathematics, that the dissociation constant of water can now be written as 10 raised to power minus 7 times 10 raised to power minus 7. From your mathematics and your knowledge of indices, when you are connecting them with what? Multiplication, it's going to give you nothing but 10 raised to power minus 7 plus what? Minus 7. Minus 7 minus 7 will give you minus 14 moles per DNK. So this is the constant value at 25 degrees Celsius for the dissociation constant, or for the what we call ionic product of what? Water. So please, guys, why we are actually giving you this is what? For you to know that there are different factors that affect how a particular substance what? Dissociate or ionize. When you dissolve something in water, you say it's ionized. I hope you understand the language of chemistry. And when you say you dissociate something, that means what? It's splitting out. And when it's split out, that means you're going to split out into different concentration. This is just basic knowledge, and I need to introduce you to this, and that is why I'm actually starting with this before going to the main work. Admin, please, let's move to the next slide. Thank you very much. Now, about this now, we are getting into the work of today, which is basically the pH scale, the common ion effect, and some factor affecting acidic strength. Now, a quick summary about pH scale. I'm not going to waste your time on this, I promise that. When we talk about pH scale, apologies guys, I just have to make sure. Now, pH, you have learned from junior classes that pH is given as a negative log power of what? Hydrogen ion to base 10, if you like writing it like that. And the other one, which we call POH, will be equals to negative log power of hydroxy ion, that is OH minus concentration to base 10. So you can write this one as H3O ozonium ion, and that is why I said you have to have the fundamental basic definition of acid, base, and salt. But I haven't said that, even if you don't have the fundamental basis of that, if you listen well to what I'm saying, you are going to get this. Now we know pH scale ranges from 1 to 14, the box from shorty note, which you know very well. So the scale of pH is from 1 to 14. You know, if pH is equals to 7, you guys say it is what? It is a neutral solution, or what you call buffer. We are going to talk about that too. So if pH is less than 7, everybody know, we say it is what? Acidic. Quick revision. And if pH is greater than 7, say it is alkaline or basic. The quick revision also, as you move towards the left, the concentration becomes more acidic, and as we move towards the right, the concentration becomes what? More basic. I hope students are actually getting that. All these are very important stuff you guys might have studied in your junior classes. I just believe you've done that. So that's that. So let's see in continuation, because what we want to learn is beyond that stuff. So now, if we move forward, I hope I'm not cutting my dear admin. Thank you very much. Now, if we move forward, we can say from what we've just studied now, I want to use the black fine. Now, from what we just studied now, I haven't had the idea about pH and whatever. So when the pH of a solution is neutral, it can also be called a buffer. A very good example is water that we talked about the ionic equilibrium the other time. And you can see that what it gives us the total formula you guys have studied on pH to remember this formula that says the pH of a substance multiplied by the pOH of a substance is always equals to what? 10 raised to power negative 40, because water is neither what? Acidic or basic. And that is what we calculated the other time. I hope it is now making sense. Try to be what? Bringing them together, because we are actually going somewhere. Now, having said that, we need to talk about an important fact which we call the common ion effect. Yes, this common ion effect is very popular in your UTME. Even sometimes you see it in WAEC on this topic. Apart from the calculation aspect of the pH formula, which you might have also studied in junior classes. Now, when we talk about common ion effect, from the word, I'm going to make everything elementary. From the word common ion, that means there is an ion that is what? Present. So when we study weak acid and weak bases, which we call buffer acids and buffer bases, please listen, terminologies are coming now. Now we look at some ions that are, when substance dissociates, they form ions, which we call what? Concentration. We measure in terms of concentration. Now, let's take a very good example. When we say common ion effect, how does it affect a solution? I haven't said that this is the formula for pH and this is for pOH. How does it affect solution? Let's take a very simple illustration which every one of us actually know very well. Let's take this simple explanation about common ion effect. I want to give you a simple ion which we are going to dissociate. This is we did this one the other time. What do you call this? Ethanoic acid. If we ionize this or we dissociate this, it's going to give us CH3COO minus then plus what? H plus. Now let's dissolve this particular ethanoic acid in water. Let's say we have water. Water is H2O. If we ionize water or we dissociate water, we split water. Water is going to give us what? H plus and what? OH minus, then what? H plus. Now, if I ask you a simple question from what you can see, what is the common ion in that solution? The common ion in that solution is nothing but what? The what? The hydrogen ion. And you know the implication of hydrogen ion. Now, the implication of common ion is that it simply means, you can see, remember that this part of the substance is called the reactant. I hope I am visible. And that other part is called what? The product. Remember the chapter of your equilibrium before this in junior classes. Remember the concept of Le-Chatelet principle that says if one side is being what? Disturbed, the other side try to balance out. I am not quoting definition. I am trying to explain. Now here, if you see, because of common ion, which is H plus, what will happen to that reaction? The reaction will favor the what? Because it's at the product side. So the reaction is what? It's now what? Favoring the right side. So according to Le-Chatelet, the reaction will now what? Try to adjust itself backward. So what we are trying to say is that more of H plus is what? Is being produced according to this. Why? Because of common ion effect. So when there is the same what? Particular ion in a particular reaction during dissociation of what? A weak acid or a weak base, the ion common to both of them is what bring about how the nature of that particular substance or that particular element or compound are going to behave. So in this case, my dear students, look at our question will now ask that what will happen to this acid now, CH3CO, that is now dissolved in water? What will happen to it? Because you know that when you look at this guy, everybody knows that pH is equals to negative log power of hydrogen to base 10. Now in this equation that we have here, what happened to our acid before? The acid now has increased in concentration of hydrogen. When it has increased in concentration of hydrogen ions, you know it is what? You'd expect it to be what? More acidic. Am I communicating? And these are questions you see. Now because of common ions that are present in that what? When this thing is being what? Dissolved in water or any other substance that is common in there, it produces more H plus, which makes this guy to be what? More acidic. Now because of that, if it is more acidic and there's increase in the concentration of H plus, sometimes it may not be H plus, it may be H3O plus. Definition. That's why I said the concept of what? Hydronium ion or oxonium ion, anyhow you call it. Now, if there is an increase in concentration of H plus, what do you think will now happen? Now, what will happen to pH? Because pH is a measure of what? H plus. Because it is the negative measure. So that means the pH is going to be, you can see now, the pH value is going to, because, listen guys, H plus is increasing. H plus is increasing. So if H plus is increasing, that means the pH is going to be more negative. So the pH is going to what? Decrease. Do you understand my point now? Because pH has negative of H plus. So H plus is increasing. So negative of it, the higher the negative number, the lower you set the value. For example, -2 is lower than -1. So if H plus is increasing, that means minus H is now increasing. So when that one is increasing, what do you say happen to pH? The pH is what? Going down. So please note this. So that is how we say what the pH here is what? Reducing. reduce. So if it is other way around, if what if OH in this case now, if OH is now decreasing, if OH is decreasing, what will happen to the value of the something pH will be increasing. If H plus is decreasing, what you expect? You expect what the pH to increase. Please note that. So that is these are logic we use to understand. So if H plus is reducing, the pH will be increasing. So if H plus is increasing, the pH will be because of the implication of these negative signs. And that is what we call the common ion effect. So please keep that in mind. I don't have so much of time, and that is why I have to increase my pace a little bit. Now, about that will now lead us to the last aspect on this part, which talks about factors affecting the acidic strength. That is talking about the level of the acid. You can see, now one of the factors that you can see, there are a lot of factors I can list out here, but also because of my time and other things I have to still explain, a lot of factors you can always keep in mind is talking about the rate of dissociation. Talking about the rate of dissociation. Now, if a particular substance has the ability to dissociate easily, that means the bonds are not held together tightly. They are weak acid. So because it can dissociate easily, you expect that particular substance, when it to have the tendency of forming more acid. So the first factor is what? Dissociation rate. So I'll just write it in language form. Dissociation rate. I'm talking about the factors that affect acidic strength. So dissociation rate, let me write it mathematically for ease of access, is proportional. Dissociation rate is proportional to what? Acidic strength. So that is what we are saying here. Hope I'm not cutting my admin. Let me just write here. If you have HA as an acid, like this, we've talked about this in the beginning, and it's dissociated to be H plus, then A minus. Now we can put that, put this in brackets. If this thing is dissociating to produce more of H plus every time, that means more acid is being produced. And when more acid is being produced, it's because the bond is weak. So you can also say then it's also now inversely proportional to the bond strength. So these are the way I explain things, the strength of the bond. So keep this in mind. The more the substance can dissociate, the more the acid will be formed, and the lesser the bond, or the weaker the bond. I hope you get this analogy. Another important thing before I move to the next part is also to keep this in mind. Maybe I create a new page. I just hope I don't just check this pause, please. Up till now, we have learned about what we call dissociation constant, the pH relationship with the pH. Now we talk about ionic equilibrium, and we've talked about the pOH and how to determine or some factors that affect acidic strength. If you miss that particular type, I also talk about another important factor, which I call the process of everything is just excessively big. Apologies, guys. I just want for us to be able to see what I want to talk about. I talk about factors. I said the first thing is the acidic strength is affected by pH, polarity, and the dissociation, which I was able to explain. The other one you missed because of the interruption of network was the one I talked about when there's increase in polarity. Well, there also be increase in electronegativity, then what we call the acidic strength will also be increased. What do I mean? We know the electronegativity definition was taught well in junior classes. So the more the increase in the electronegativity, the more the polarity of an acid, and the more the strength of an acid. I talk about the dissociation the more they work, the more the weaker bond, the more what they dissociate, the more acid is being formed, the more the what acidic strength. So these things are very important for you to keep in mind. A quick one, because there is no more time. I have limited time left to complete this chapter. I've been only giving me 45 minutes all, but I still have exam type questions to solve. Now about buffer solution, important thing we can write. Now we say buffer solution, we've defined our just solution that is what? Unaffected. Solution that is unaffected by change in pH. So that is, I'm sorry, I'm going to increase my pace a little bit. So because they are unaffected by change, we have talked about water India as an example. Blood is also another example. I'm not going to that. So we classify this buffer solution into different categories. Now the categories I'm going to talk about, I have what I call acidic buffer. Just understand this once and for all, and the basic buffer. So how do we form this? We say they resist a change in pH. Any definition, those are grammar, which you can all do. Now, having said that, we can also let us understand what we call acidic buffer. We are talking about when we meet a weak acid plus a salt of the acid, we are going to have acidic buffer. And the same thing goes to this. It will be the opposite of everything. It will be a weak base plus a salt. Because of time, I will be rushing. I'm sorry, guys. I have to finish up everything in just the meantime. Now, here we should be able to understand how this can be done. Thank you very much, Admin. Now, let's quickly look at, for example, what I mean by acidic buffer and basic buffer. Let's take a look at it briefly. Talking about CH3COOH. Now, when it was ionized, it will give us CH3COO minus. Why I'm teaching this is for it because of exam question. Then we have our plus what? H plus. Let's take the salt of this acid, which will be CH3COONA. Everybody know this is called sodium ethanoate. Please note that in organic chemistry we talk more about that. So we dissociate this going to be your CH3COO minus plus what? Na plus. Now, if we talked about this, you remember what we talked about? We talked about what? Common ion effect. What is the common ion effect? This guy. So this guy should be a reversible reaction. That's first condition. So here in this case, we can see that what? The amount of what? The amount of hydrogen ion here is reducing because the one that is common is increasing. So hydrogen ion is reducing. That is why we said this is called an acidic what? Buffer. Because when hydrogen ion is reducing, you know pH is equals to negative log power of hydrogen. I told you when hydrogen ion is reducing, that means what? What this means is what? The amount of the pH is what? Is going to be what? It's going to be what? Opposite of that. So please note that because you have negative. So it is reducing, pH is increasing. So what we are saying here is that what? Acidic buffer is formed when weak acid combined with what? The solution of the salt. And when weak base mixed with what? With the salt, it's going to give us what? Basic buffer. The same thing happens to, we can take an example, I don't want to waste your time. Like, if you look at consider NH4OH, this example of a weak base. So weak base here, we ionize or dissociate rather to give you NH4 plus OH minus. Then the solution of the salt, you can do that as an assignment. This one will give you NH4 plus and Cl minus. OH will be produced. More of NH4 will be produced, and you know what that means. Concentration of base is reducing. Then when concentration of base is reducing, we expect the pOH to increase. When concentration of base is reducing, that means that of acid is increasing. When that of acid is reducing, that means that of base is increasing. And that is what? The knowledge of your what? Buffer solution. Then why do we need to learn this? Because I always ask myself that too when I am at your level. Now the reason why we are learning this is to understand the concept of what we call the hydrolysis of salt. Now there are 4 basic categories which I'm going to do by adding a page to what I have here. So I think I will do that myself now. Admin please reduce the quantity of this. Give me one page. Let me see if I can quickly explain the 4 step in which we use for hydrolysis of salt. I have less than, thank you very much, just a plus here. Yes, I think this will be okay for me for now. So if I have this, am I visible, please? And if I'm not, we can change it to white background. I think it is not better. This is background management. I think I will use white for me to be well visible. Now, there are 4 explanations we give to hydrolysis, which you might have studied in your junior classes. From the concept of both one, we can understand. So just keep this simple note in mind. When you have a strong acid plus a strong base, do it in terms of your pH. You have a strong base and a weak acid. You have a weak base and a strong acid. And the last one is weak acid and a weak base. So from what we just learned now, we said a strong acid and a strong base, we are talking about pH. The pH will be equals to 7. When pH is equals to 7, that is a buffer. And that is what we're talking about. So if our A-level students, their formulas we bring from here. We add each what? The pH plus the pKa plus what? The log of what? The hydrogen ions of the salt over that of water. But I'm not going to the calculation in this video, like I said. Now for weak, strong base and weak acid. Now we can see strong. So it means it will be more basic. So when pH is more basic, that means pH is greater than 7. Weak base and strong acid. In that case, weak base from acid, that means it will be more acidic. That means pH is less than 7. Please, this is important. And the last one, weak acid and weak base, we say, most times we say cannot be neutralized. So this is it about these slides. We just need to understand this is the concept. And when we see question on it, most of your questions will fall on this one. Admit next. That's it. Thank you very much. Now, about this one too, for understanding sake, and for you guys to see what I have before me, let's quickly look into what we call solubility product. I think this is the last slide. I'm sorry guys, I have to be very, very fast. Now, when we talk about solubility product, solubility from junior class is defined as the amount of solute in 1000 dm cube of a solution. But here we are talking about the solubility product. I will make it short. I am sorry. Now, the solubility product of a solution is what? Of an ion is written as KSP, and it is only applicable to sparingly soluble, let me just say it, sparingly soluble or insoluble salt. First fact you keep in mind. So it is only important to sparingly soluble salt or insoluble salt. You know, we are talking about common ion effect, we're talking about ionic equilibrium, talking about weak acid and weak base. So when you talk about the dissociation of a substance, let's take a very simple salt. I'm going to make it fast. Silver chloride, which is popular everywhere you go. Now it's a reversible reaction when it ionizes Ag plus and Cl minus. So if you want to write the solubility product of this, it is only a dependent of the what? Of the concentration of the product. Unlike your Kp and Kc which we've done, they don't Ka or Kb, that's for acid and for base, which we've talked about. Unlike them, that depend on both the reactant and the product. So solubility product is only applicable for sparingly soluble solution or salt or base or acid, as the case may be, and they only depend on the concentration of this. Now, basically, you know, if you want to write active masses, this is where most of the students make mistake. Now, if you want to get the KSP of this one, we now say let's this be X, because this is 1 mole. You can see 1 mole of this, 1 mole of this, and this is also 1 mole. That is X. So that's the concentration of each of them. So we now say the KSP is now equals to X times S is X squared. So if you want to get the concentration of X, it will now be equals to, everybody know, square root of what? The KSP. Now the concentration of X in this what? In this particular solution. I'll take one more example for you guys to get. Let's say I have CaF2. first thing you write is what? You are going to write what? The dissociation equation. So everybody knows that this is as a result of Ca2 plus what? F what? Minus. Then we cross multiply from Berzelius rule to have this. So if you write that, we're going to have Ca2 plus, then what? You have F minus. But there's something you need to know. When you are doing this, the amount of mole of this particular substance is 2. And because it is 2, the 2 that is here is always going to be at the back. Please note that the 2 that is there, and that is why we have written. So to write the KSP, we now say the KSP of this particular salt will now be equals to, this is X. Then when you want to write a number that has a mole in front of it, it is always raised to the power of the stoichiometric coefficient. I hope students still remember that. So here it is now 2s raised to power 2. Please don't make this mistake when you are solving. Now this 2 is the one that is floating over. And that is the way we write mole, when we write what we call equilibrium constant. Do you remember that under the concept of equilibrium, chemical equilibrium? So directly we now say KSP here is now going to be equals to, this is 4x squared times x. This is 2 times 2, 4. 4x squared times x is 4s cubed. If you want to get the concentration of x in this soil, x will now be equals to, it will be the cube root of KSP divided by 4. And I'm only doing mathematics here. And these are the methods I want you guys to follow. When you have mole, put the mole by the side and also remember to shift it to the top. This is the way we do this. And let's see some example which I'm going to quickly solve in no time. Thank you, Now the first question. The first question here says which of the following salt, when dissolved in water, will not give a corresponding pH value? That means the one that can, a buffer solution that cannot be hydrolyzed. What do we talk about? A weak acid or in a weak base. Apart from that, which one will not give a corresponding pH value? This examiner has tried to give us pH value of each of them. So how do we know the answer? Let's start. This is sodium and this is HSO4. As you can see, my dear student, this is a sodium hydroxide, which is a strong base. And this is a H2SO4. So now, they're very good. I like this type of situation because you have to think. Now, this is a strong acid and this is a weak base. H2SO4 is a strong acid. NaH is a what? A weak base. Now, NaOH is a weak base. So, NaH is a weak base. Now, what we are going to do here is that when we have strong acid and a weak base, strong acid and a weak base, we know that there's something will be more acidic. Strong acid, weak base. So, this is correct because pH is less than 5. Look at this one. Na2CO3. NaOH is a strong base. HCO3 is a what? The weak acid. So strong base, weak acid, strong will take over. So it will be what? More basic. When something is more basic, it is greater than 8. Because you know basics are what? Are greater than 8 on your pH scale. Now the next one is I can't see this, Cl. NaCl is from strong acid and strong base. How do you form NaCl? NaOH plus HCl. I hope you get that. And I told you NaOH plus HCl, that is strong acids and strong base, will give you a pH that is equals to 7. So this is also very correct. So that means the incorrect statement will be this one. So let's see why this is incorrect. This is formed as a result of NaOH plus HCO3. So that is like strong base and what? Weak acid. So it will be more strong base. That means the solution will be alkaline and it should be greater than that. So please note that the answer to that is that. The next one, that. Thank you. Now, the next says a question on concept. The greater the difference in electronegativity between bonded atoms, the dash. I talked about this, talking about the strength of acid. The greater the electronegativity difference, the what? The more the polarity. And the more the polarity, the more the acidic strength. Please note that. So the answer to this one will be the weaker the bond, the higher the polarity of the bond. B option will be correct. Next question, Andrew. Thank you very much. Yeah, fine. Question on solubility product. 1.0 dmK of distilled water. We know distilled water was used to wash 2 grams of a precipitate of silver chloride. The solubility product of AgCl, silver chloride, is this. And what is the quantity of silver that was lost in the process? Water was used to what? And we've talked about water being a buffer solution. It will have no effect. You understand that now. So doing this, we just need to follow the KSP of AgCl. We did this as an example. It will be what? Ag plus, then Cl minus. Taken? So if we've taken this, we can now say the KSP now equals to X 1 mole times X. So that is KSP is equals to X squared. Apologies guys, I'm rushing. So going by that, what we do is now, we now substitute value. We are given the solubility product. I think we're given, 2.0 times 10 to the power negative 10. 2 times 10 to the power negative 10. Most square equals to X squared. So we are looking for X. The concentration of what? Of AgCl. It will now be square root of 2 times 10 to the power negative 10. Square root of 2 is 1.4, 10 to the power minus 5. So I'm looking for something like that, very good. 1.414 times 10 to the power negative 5 moles per year. So that is how to do something like this. And that will tally with, I hope you can see this, with option A. And that is the correct answer. The next question, Admin. Thank you very much. Which of the following in aqueous solution is neutral to litmus? Solubility, buffer solution, we have studied. Now, the one that will be neutral to litmus will be the one in which what? It has what? It is made from what? A strong acid and a strong base. So, which one is formed from strong acid and strong base? This is wrong. This is formed from what? Weak base and strong acid. This is formed from strong base and weak acid. This is formed from, you can see, this is a binary salt. But you know that FeCl3. So, and this is the answer because NaCl is from what? NaOH, which is a strong base, and HCl, which is a strong acid. So that will not be hydrolyzed, and that will give you what will be a buffer solution, and that is why we said this is going to be neutral. So next question, admin, which I think is the last one. Thank you very much. The last question, not last, the main one. Thank you. Sodium chloride has no solubility product value because I talk about solubility product is only applicable for what? Insoluble or sparingly soluble salt. Sodium chloride is what? It's very, very soluble. You know that very well. So it doesn't have a particular value of what? Solubility product because it's what? Highly soluble. Solubility product only work for what? Sparingly soluble salt. All these are very important for you to keep in mind. Last question, my dear. Thank you. Now, for the last question, nothing to solve. A few drops of concentrated HCl are added to about 10 centimeter cube of a solution of pH of 3.4. pH is already acidic. Then we are adding hydrochloric acid, common ion effect. We talked about that. Hydrochloric acid is also acidic. So we are adding what? We are adding the pH is 3.4, which is acidic. So we are adding what? We are adding more acid to it. What do we expect? Common ion effect. That is what I mean by common, because it will produce what? More of what? More of what? Hydrogen ion. Please keep that at the mark of your. So if more of hydrogen ion is produced, what do you expect? Today something, it means what? It will be more acidic. So I said it will be more acidic. When more of hydrogen ion is produced, I told you formula for pH is minus log of hydrogen or ozonium ion to base 10. So it will produce more of hydrogen ion. When it produces more of hydrogen, what happens to pH? The pH will what? Reduce because of this minus sign. I talked about that in the concept. So what happens? It will be less than that. So always keep that in mind. The pH will go down. So it will be less than 3.4. Please, that is how to solve questions on this topic. So I believe you guys really enjoyed the class, and if you do so, you can kindly subscribe to this channel and click on the notification button for you to get what? Notified when we are going to post the next video. So guys, I'll see you soon in my future video. Do have a wonderful time, and bye bye for now.